Condition-based maintenance is the marriage of the two most important maintenance strategies or philosophies. It's doing maintenance on conditions. So we have to monitor conditions, and then when we identify something that requires a response, we take action. So the two subtypes of condition-based maintenance are proactive maintenance and predictive maintenance. Predictive maintenance is symptom monitoring, failure symptom monitoring, fault monitoring. So there has to be something going on, an impending failure condition, perhaps a precipitous failure condition, real near-term failure. But the best we can hope for is what we call incipient failure. Incipient failure is a weak signal that we detected that indicates that failure is in very early stages, and it's something that we can respond to, we have time to plan for, we can correct. So we're going to use different technologies for predictive maintenance. There's a lot of different possibilities out there, and they need to be used together. We don't want a single toolbox here. We want a complete toolbox with all the possibilities of being able to detect problems and detect them earlier. One of the best tools that I know of is what is called wear debris analysis. We're going to look for wear particles. After all, when machines wear, they produce particles. Where do the particles go? They go to the oil. They can go from the oil to the filter, to the sump, to magnetic plugs. Wherever those particles end up, we need to find those particles, analyze them, and understand what they mean. Vibration analysis, definitely a good technology in the kind of predictive world. Thermography, motor current analysis. So again, the main objective here is early detection of faults and failure. Proactive maintenance, different concept. We're looking for root causes. We're looking for what could become an incipient or impending failure conditions. So we need to understand how machines fail. And this is one of the reasons why when machines do fail, we need to do what we call root cause failure analysis. We need to ask the repetitive why. What caused the bearing to fail? What caused the lubricant to fail? What caused the lubricant to become contaminated? All the way back to something that we can control and correct next time around. We've talked about the silent functions of the silent assumptions of machine reliability and bearing reliability. These include a lot of things depending on the type of machine and its exposures, but definitely contamination is in this area. Mechanical things such as balance and alignment, the type of lubricant, the quality of lubricant, the condition, the viscosity, all relate to root causes. So what we're trying to do with proactive maintenance, again, is not to detect failure, but to prevent failure from starting. Fixing what might cause breakage, achieving fault-free machine operation, to extend the life, to slow down the rate of wear if we can. So if a machine normally has 10,000 hour service life on average in a given operating environment, including loads and speeds and temperatures and these sorts of things, what can we do to enable that machine to have twice that much life, 20,000 hours or 30,000 hours? Well, certainly we have to have some sort of intervention. We have to do things differently. Pareto teaches us that what we need to do differently needs to be the things that are most prone to cause wear, the 80-20 rule. So we need to understand what those things are. So proactive maintenance relates to fixing what might cause breakage. Predictive maintenance relates to fixing what is breaking, what is currently breaking. It's not broken yet, because that's breakdown maintenance, which isn't, in a sense, a condition, not a condition we want to see. But instead, predictive maintenance is identifying a current condition through symptoms and fault monitoring, and correcting those conditions before a small problem becomes a much larger problem.